Hi, I'm Damien from DK Engineering and Machining. We are a job shop based in Brisbane, Australia, and we're going to do a small shop tour for you today. I'd just like to thank Practical Machinists for giving us the opportunity to showcase our shop. So let's have a look. So I'm Damien, I am the owner of DK Engineering and Machining, and a bit of a background on us and how we got to this stage. I am a design and manufacturing engineer, got qualified in Ireland back in 2011. About 8 years ago, myself and my partner moved to Australia and started working in a few different roles, welding, fabrication. I always had a big interest in machining and fabrication, so I found an old Colchester Master 2500 off Marketplace. It's what we would have kind of learned in uni what to turn on. So quickly cruised down the coast to pick that up and brought it home, got it into our basement in our Queenslander house and converted it to single phase, obviously, because you don't have 3 phases at your house, with a cheap eBay variable speed drive. Started doing some work with the lathe, some fabrication work at home. We stepped up to look for a universal mill. We went to a local shop that was selling one to buy it, and then we ended up, he was getting out of his shop, so we overtook his lease and we moved into our first shop. That first shop was 88 square meters. We had Colchester lathe, we had a Condia universal mill, we had a fabrication area, and yeah, that's really how we started. Started to get some manual machine breakdown work in and some fabrication work. We had developed a product and brought it to market called Quick Fab, which is our own brand of fabrication tables, so manufacturing them. We were looking at CNC mills for a little while, and we ended up buying a Sile X7, and while we were waiting for that to be built, we were outsourcing some turning work for our fabrication tables, so we picked up an old 3-axis Hitachi Seiki, all manual programming, G-code. Done a lot of head scratching, getting up to speed on that, and then very quickly started to get a lot of job shop mining style work in, spacers, bushes, that sort of stuff, and that very quickly grew and we could see a good potential in it. So after about 8 months of running both of those machines and getting pretty busy, we could see the need for some automation, and we done some research, and then we decided to go into the deep end and get brand new twin spindle Y-axis lathe. So we done that, and 8 weeks after we got that, we actually moved shop into our current location, which is probably about 300 meters from where we were. Bigger shop, 152 square meters on the floor, and yeah, we started focusing a bit more on the machining side of things. We actually put it in a 5-axis trunnion-based machine as well, and we ran that for probably about 12 months, and then about 6 months ago we sold both the 5-axis and the small 4-axis, and we stepped up to a large 4-axis machine to deal with the sort of work that we were doing, and that's pretty much where we are to date. We're coming up to 5 years in operation, 4 years in a workshop, and the main industries we service are mining, automotive, general fabrication, general manufacturing, and pretty much anything in between. Okay, so this is the shop. We're here 16 months at this stage, so it's about 152 square meters on the ground. We have mezzanine above that gives us another 40 square meters. So when we moved into the shop, it was pretty much a blank canvas. We found a shop down in the Gold Coast that was they were vacating, and they had a mezzanine there that they wanted to sell. So we went down, and myself and Chris, who works for me, we pulled down the whole steel work, the timber floor, the joists, everything, and we got it freighted up to this workshop, and then we made new columns and stairs to make it fit here. So it's for me, with the old workshop, we had an office on the ground that was just a studded partition. If I was working in there and somebody was on the lathe, I was getting chips coming across and hitting my head and stuff like that. So to get the office space off the floor was a big thing for me. So that's why we went with the mezzanine. So here is our sort of dispatch and in-feed area. We've probably changed this shop layout 4 times in 16 months, and it'll probably change again. It's a rolling evolution. So recently, we just put our dispatch area over here. So goods in, new jobs come in here. All finished jobs come out here with job cards. So a big thing for our progression is that being a small company and bringing people on board, I don't want it to be solely dependent on me to sort of make sure everything goes to its right places. So having processes and workflows in place has been a big sort of thing in my mind while we've been building the business. So yeah, basically all our jobs coming in and out goes onto these shelves. We have job cards associated with each job that gets taken upstairs and sort of allocated materials and stuff like that. We've got a small sort of packing area here. This is where we can clock in, so whoever's working on the day can clock in using Clockify system, just a very simple clock in, clock out system. And then we got some packaging materials, boxes, weighing scales, tapes and stuff like that to for any boxing up for any goods going out. Over here is our fab area. As you can see, it's underneath the mezzanine. We tried to run multiple power outlets, so we're not restricted. We're not trying to run cables across the ground, just trying to make everything as clean and neat and tidy as possible. We've got some air rails there and over there, again trying to keep everything off the ground. This is the first product, OEM product, that I developed while I was working out of our basement in our home, which is called Quick Fab. So at the time of development, there wasn't really a workshop worthy version of a fabrication table that you could buy within Australia. You could get some high-end ones imported from Germany and America, but very expensive. So we developed our own range of laser cut tables, but to the level of a machined table. So the tolerance of our inserts is pretty much comparable to a machined table. So we brought these to market and quickly started establishing a bit of a reputation. We've sold them to private individuals in their home hobby workshop. We've sold them to companies in batches of 5s. We've sold them to TAFE colleges, which is your student colleges in Tasmania, all up and down the east coast of Australia. We've got some V8 supercar drivers running them as well. Quite a widespread market for that. Again, we started these underneath my house, which was very difficult, but we were able to bring quite a high level product to market in a less than ideal workshop. Quickly scale up, and time implications of trying to manufacture these and sort of learn the CNC side and machining side, it sort of became apparent that I couldn't do this on my own and grow the business. So that sort of led us down to look at bringing people in. But anyway, that's another story. So yeah, basically that's our Quick Fab. You can see we got some motorbike repairs on the table there at the minute. This is actually a Kawasaki ZX6 stunt bike, which is my background as well as like a freestyle stunt rider. So this is a local rider who's actually snapped the back half out of his frame doing tricks. So we're just repairing that for him. We got a standard frame there. We're taking some measurements off. Yeah, so fabrication area. We did do a lot of heavy fabrication frames, just whatever will come in. We've sort of tailored back from that just because of the scalability of it. We don't have a lot of space here, and we need lots of manpower to scale fabrication side of the business. So we're more focused on the CNC side of things now and machining. So this is sort of more so as a support to the machining side of the business now. We go over here, we got a hydraulic press there. We got our Kempy X3 MIG welder, and we got a Lincoln Powercraft TIG welder there. Yeah, that's pretty much the fabrication area. We'll look at the manual machine shop side now. So yeah, we've got a manual lathe which is 1100 centers. I think we got 56 mil through the spindle, and we've got a global universal mill. So originally I started with a Colchester Master 2500 in my garage, and then we moved that to the shop, and then moved that to here. Actually no, we moved it to the previous shop. We ran it for maybe a year and a half, and then there was a business going out of business, so there was an auction. We had a look at this. It gave us a bit more capacity. It gave us the opportunity to step back up to a 3-phase lathe, so we could run bigger parts and not have power issues. So basically picked this up for a pretty good price, got it over here, done some modifications, lifted it up, and that's our bread and butter lathe now. We got our global mill here, so standard universal mill, has a horizontal bore on her. Yeah, we have all your generic sort of manual stuff. We got dividing heads there, we got rotary table there.
Is this the mill that led you to take over the lease originally to get into your first shop?
No, so actually we've only got this mill probably in operation about 6 months. So originally we bought a Condia universal mill, and we've ran that for yeah, probably about 2 years, 2.5 years, and it was a NT30 spindle taper, really good mill. And then a friend of mine actually bought this machine brand new, and he was upgrading, and they had an accident when they were offloading the machine into the workshop, and it fell over and got damaged. So he got reimbursed through his insurance and stuff, and then this one became available damaged. So we bought this, and we were able to source all the parts from the original manufacturer, get it back over. Our bed was all, our casting was all cracked. Our ball screw had snapped. The electrical cabinet was bashed and twisted and whatever, so we replaced that. Our manual machinist at the time fixed the ball screw. We got a new cabinet for it. We took the internals out, the back plate, we put that back in, and for a pretty good price we were able to get refurbish this mill back to pretty much a brand new milling machine. So
does this have the same capabilities as the old mill, or is it different in the way?
It's bigger. So the old mill had auto feed on your x-axis only, so we've got X, Y and Z on this. The big thing for us is trying to speed up your processes. So pneumatic tool changer on this makes a big difference. So we can set up a few of our standard tools, which you can see over here. We can have them in the machine, on the wall, ready to go, so we can just swap over, quickly get in, not constantly changing out tools or loosening and tightening drawbars. It's also got a bigger travel. It's got a horizontal bore on it as well, so we didn't have that on the previous machine. Nicer sort of control system and a variable speed. So the previous one was pulley and belt driven speed change, so now we can change with our hand wheel here. So nice upgrade for probably a quarter of the cost of what it cost us to buy a new one. So yeah, the manual machine shop, we've sort of got it quite condensed because we're loading some big parts in the CNC at the minute, but we try to make sort of cells in the workshop. So there's a nice little cell where you got your mill and your lathe, you got your workbench, and you got your tool wall here and here. So we've sort of invested a lot of time and effort into trying to get everything sort of standardized and organized, I suppose. So you can see we've got tool wall with sort of your generic tools are there and they're labeled, so quickly and easily you can go and you can grab the tool that you need. The same over here, we've just made little racks for holding our tool holders, like that, so they can go on and off. Quickly you can see what you have. All our faceplates, 4 jaws, steadies, all our soft jaws for our vices, collet holders. That's something that I actually designed a few years ago, and little things like that. It takes a bit of time to make them, but it just makes our working life a lot easier. Both if it's me that's working here or if I have people working on the machines, and very easily if somebody new needs to come in, it's self-explanatory. They can figure out where the stuff is, what to use for what, and it's not like hidden in drawers and stuff like that. So
I can see that the workshop's really tidy. Is that something that you prioritise on a regular basis, or have you just tried to doll it up for the sake of the video?
It's definitely not always this tidy. It just really depends on how busy we get. We do have a heavy emphasis on standardization and keeping things tidy and putting things away and just general cleanliness. I have worked in some pretty backward shops in my time where stock is on top of stock on top of stock, and nobody really knows where stuff is, and it just makes it very difficult. So yeah, I don't mind people taking time to sweep the floor, keep everything tidy, and if it's done on a consistent basis, then it just makes it easy. It's just what you do, and it just makes our work day a lot easier, and you're not tripping over things to get to things and people getting angry and stuff. So it's a little bit tighter than it is, but it's normally pretty tidy. We do get a lot of people coming in and making comment about how clean the workshop is, which is it's always a nice thing to hear. So yeah, we try to keep it as clean and tidy and organised as possible. So over here we have a little system for how we schedule our jobs. Again, there's a lot of talk around like companies and ERP systems and digital systems to schedule your jobs and manage your jobs on the floor. I've always had a big interest in like lean manufacturing principles and the basics of lean, not like you can go really in depth into Six Sigma and stuff like that, but we watch a lot of Jay Pearson from Pearson Work Holding in the States, and Ryan Tierney in CT Matters in Ireland, and basically putting in like the very core principles of lean manufacturing and organization and stuff, and 3S is that's a big thing for us. So when we got to this shop and we started getting busier, and we put on a fabricator and a machinist and then myself, I tried to put a bit of effort into how we take jobs from upstairs to how they flow through the workshop and how they get completed and then back up to the office to get invoiced out. So we come up with a paper system that we've implemented, and we're going to develop and get all the kinks and bugs ironed out, and then at that stage then we might look at a digital system. But so pretty much we've got 3 areas in the shop. We got our manual machining, CNC machining, and our fabrication, and we color code each area. So our manual machining is yellow, our CNC machining is blue, and our fabrication is green. Every job that comes in, it will get a job card with a job number, and the drawings will be allocated to that job. So that sits in there. Every job will get a corresponding schedule card. So they're just a small card that gives you the details of the job number, the customer, and basically shows you where it's scheduled on a 3-week basis. So when we're busy, we try to schedule out for 3 weeks, and we've only got manual machining jobs up on the board there at the minute, and the CNC machining job is on another board that we'll show you. But pretty much if people come into the shop, your fabricator and your manual machinist, they can take a quick glance at the board. It's color coded. They know that we have 3 fab jobs and 6 machining jobs to do this week. They can look at the schedule card, get the job number, they can move that into your in progress column, grab the full details from there, go and do your job, come back, that completed job will go into a completed section over there. That job can move into our completed folder, and then you just keep moving on, and then it makes it very easy for, if it's me that's doing the invoicing or somebody else, to pick up the job from the completed folder, invoice it and ring the customer and say that it's ready.
It sounds like it would make doing paperwork and invoicing really independent without having to go and talk to, say, the fabricator or the machinist. You could leave them do their work without even having to bother them and still understand where they're at in their day or their week just by locations on the card and the board.
Exactly, and it's basically trying to take the decision-making process off my plate, that they don't, like, nobody has to come and ask me what's next, what do you want me to do now, that job's finished, can we invoice it or whatever. So they just pretty much look at the job schedule board, they pick it off, and the answers should be on the drawings. If I'm doing my job properly, they should have all the details on that drawing to do the job, complete it, let us know that it's finished, and call the customer.
If everyone does their paperwork with respect to their role in there, then it should be fairly self-sufficient.
Should be, yeah. So we have another one over here. So we've sort of split it up with manual machining and fabrication goes to this job board here, and then we move over to the CNC area, and then we've got pretty much the exact same system for the CNC. So you can see it's all blue here. So again, we've got our scheduled jobs that are lined up for this week and next week. We've got our job folders with our job cards with our drawing details on it. A lot of it could be client drawings, or sometimes we make up our own drawings in-house. So all the details should be there. If it's a CAM file, then it'll be on our system. And yeah, as we do them, we drop it into the in progress column. As we finish them, then we move that to there, and then these completed jobs go with the times allocated to it, go into our completed bin over there, and then they get taken up to invoice. So yeah, and this is pretty much the CNC area now. So you can see we have 2 spec machines. One is a sub-spindle Y-axis lathe with a bar feeder. So 8-inch, 10-inch chuck, about 400 mil diameter turning capacity, about 590 mil capacity on the length. Again, full Y-axis capability. We have live milling on axial and radial. 12 station turret with 12 tools on either side. So we can turn this side, transfer it over, and turn on the far side. So one and done is sort of a big philosophy for us, or what we're trying to get more towards too. We try and do it as much as possible and automate the machining process as much as possible, because at the minute it's pretty much I'm the only person in the shop that programs and runs the CNC. We have one fabricator slash operations kind of manager, so he covers the fabrication that comes in and any sort of flow of jobs in and out of the shop, and then we have a manual machinist that covers the manual machining, and then we have administrative coordinator as well upstairs that covers the admin side of things.
So the automation, does that help you with your capabilities, considering you're the only one in the facility that has the ability to program and operate? How does that help you move on through the day?
Well, yeah, so if we're having to do 2-op turning work and I'm standing at the machine for 8 hours a day, then nothing else gets done. So we pretty much sub-spindle transfer everything, even if it's not, it might be a little bit longer to set up, but it means that I can walk away from that machine and let it complete its order, and nobody has to deburr or anything afterwards. It's pretty much one and done. It gets spit out, put into a box and sent off, and I can go and set up the next machine to do another job.
I noticed the outfeed box on your machine is substantially bigger than the other SL2000s. Is that something that you planned here in-house, or is that something you purchased?
Yeah, so that's a new addition. We've actually been designing it for a little bit of time. So the original box is probably about that wide, and then if you need to do, you've got a parts catcher here that you can change from parts ejection on the main spindle or the sub spindle, but once you change that, you need to change the location of the box. So we took the original box and then we redesigned a larger one-piece box, obviously bigger capacity, and you've got multiple entry points here, so you don't need to move that box over and back, whether you're part ejecting on the sub or the main side. Again, we've got the full design capabilities in-house. We have good relationship with laser cutters, sheet metal folders, and then so we can outsource that sort of stuff and get it back in, weld it up, test fit it, and then a lot of the times we will, if we try and develop something for, say, our machine, we'll probably offer it as a product to sell to other people. So we can make, I think this one here, we made one for ourselves and two for another reseller. So it just makes it easier to make them in a larger batch, and then it gives other people who think it's a good idea the opportunity to buy one as well.
A little bit of a quality of life add to make it easier for larger batches and
Yeah, 100%. That's a good point there, is actually quality of life improvements is really something that's at the forefront of our mind all the time. If we can take 5 minutes, 10 minutes, 15 minutes to think of something that will improve our workflow and improve our efficiency, we always want to promote and encourage anyone to do that, people here to do that, because you're going to gain that return on investment back. They take 10 minutes to make a holder for something. If that saves them a minute a day, not having to go and look for that, it's a massive improvement. One example is tools set out for different areas of the shop. Like every area will have its own set of Allen keys. Like how many times have you been in a shop and have you walked around looking for a 5mm Allen key and there's one set in the shop, and sometimes it's over there, sometimes you could lose 40 minutes, 50 minutes a day.
I'd say I've lost probably 2 or 3 weeks of my life over the use of doing exactly that.
Yeah. So, and a set of Allen keys is such a small cost investment. You might as well have 4 of them, and then they're allocated to different areas. The same with our rubber mallets, stuff like that. So, little quality of life improvements, a little bit more investment on the forefront to try and make that work day a little bit easier. That's kind of what we always have that at the forefront of our mind. Similar, like as I said, we have lots of design capabilities in house. You can kind of see if we look in here, we've actually designed our own coolant nozzles. So these are resin printed coolant nozzle. I'm sure we can.
So, yeah.
So we'll just bring this around.
What's this?
So that is our Clearview screen. So that's a film that attaches to the inside of the screen and basically acts as a water or a coolant dispersant. So as soon as coolant hits it, it beads and drops, and it gives you a much better vision into the machine while it's running. So you can see here we got we're running some little collet holders, and normally your little ball coolant olives or nozzles, you call them, they normally come straight out and they just hit the edge of the collet nozzle or the collet chuck. So we make these gooseneck coolant nozzles, and basically it means that coolant gets exactly to you can direct it wherever you need to do it, and gets up and around the collet chuck. We actually have another style which is we've found a massive help is our ring style one. We would use these a lot when we're tapping. So it would sit in there and basically has 4 ejection points of coolant onto the tool. So when we tap on the sub spindle, we would run our Holex tapping chuck, and we would run that behind it, and basically it pumps coolant 4 points onto the tap, and then we also pump coolant from the sub spindle back through. So it's pretty much giving the tool every chance to get coolant in where it needs it most. So a few little things like that we spend a bit of time trying to develop. We've got 3D printing capabilities, resin printing capabilities next door. So we utilize their expertise to do these things to help our quality of life. Yeah, so that is our lathe. We got some tool storage here, which is all our soft jaws, basically getting them up onto the wall so you can see very quickly what jaws you have. All our collets are in custom made timber holders. Again, you can just drop them in, just having a position for them that you can quickly and easily grab them. Our tool drawers, we try and standardize. It's a bit of a work in progress, but we standardize all our turning tools, our boring tool, stuff like that. So yeah, that's pretty much our CNC lathe. As I said before, like we had an old Hitachi Seiki lathe. That's what we started with, which was all manual programming. Took us a long time to set jobs up, program them, especially like my experience is not in CNC machining. So when we got that first Hitachi Seiki, I was reading manuals and basically trying to figure out how to program G-code from scratch. We got some help from some local tool suppliers and from some friends that were in the industry, but it was a steep learning curve on how to program jobs. It would take me probably 10 times longer than it would take a competent person to set up a job and dial it in and get it running. But for me, it was that was the good foundation learning that I think needed to happen. So now when we go to higher end machines, you understand the G-code and you can jump in and make changes and not be reliant on a CAM system. So pretty much 95% of our programming on the lathe will be done on the controller, either using standard CAN cycles or manual guide eye, with the other 5% being like complex milling programs we'll drive from CAM across to it. So we've actually delved into trying to standardize our program. So we do a lot of very similar but different spacers, bushes, shafts, all that sort of stuff for the mining industry. And we've just started developing more standard parameter driven programs that cover hundreds of different parts. So we'll jump in. We've got like 5 programs here that will pretty much cover the majority of the parts, the repetitive parts and similar parts that we do. We just change our core values at the top, speeds and feeds, sizes, chamfer sizes, that sort of stuff, and it populates down. So pretty much trying to come up with ways to get the jobs onto the machine as quick as possible and running, because we do get a lot of smaller batch work. So we really need to be competitive. We need to be very, very efficient at how we set jobs up.
What made you change and upgrade to a larger machine like this? I would imagine there would be a substantial price difference from your original CNC lathe compared to this one.
Yeah, so yeah, our original lathe was an old 99, 2000 model Hitachi Seiki HT20, 3-axis lathe with live tooling, and we ran that for probably 8 or 10 months. It was a steep learning curve. Obviously we were programming fully by hand on the controller, and it would take me quite a while to set jobs up and dial them in. So I think the turning point for us was myself and my partner. we're going back to Ireland with our 18-month-old son, and we flew out on a Monday evening, probably about 7 o'clock in the evening. We left for the airport at 7 o'clock, and I think I left work at 6:15 that evening, and from Monday to Monday I had done something like 106 hours to keep. We had a large run of different parts on, like 200 quantity, 300 quantity, 400 quantity of stuff, and with the single spindle lathe, it was always 2 off parts, and it was just so time heavy, both to set up, program, dial it in, and also to stand at the machine and run parts. So I remember I sat in the plane. I didn't even know what was in my bag at the time. I hadn't been home in 8 days, and that was the turning point. It's like, we need to automate. We need to sub-spindle transfer. We need to do one and done operation so that I can set a job up and let it run by itself. And that was the way we thought we could scale it. So obviously there was a substantial price difference. With the old machine was like a 30-40 grand machine, and then these ones are in the hundreds of thousands. So we had a trip back to Ireland. We were there for 3 weeks, and then I came back and ran some numbers and worked out the time saving that I could save per part doing sub-spindle transfer, and if we could save like an hour on the setup of a job, it would make money. So that sort of solidified it for us, that we knew that as long as our business stayed consistent, that we would be able to justify a new machine. And we done some research. A company I used to work for had this brand of SMEC machine, and the local support was very good. And with the Hitachi, I had a lot of breakdown, not a lot of breakdowns, but I had within a month of running, I had spindle speed issues, which turned out to be all the capacitors in the speed drive had leaked. Again, older machines, it's very hard to find people to service them. It's very hard to find controller boards. All your electronics starts to be phased out. So we had 2 pretty big breakdowns on it, that I had to remove the main spindle speed drives, get it to probably, there's only one person in the whole east coast of Brisbane or east coast of Australia that would have the knowledge to service these things. So it was just holding on to that machine is a bit risky. New machine, you're more confident, you've got local support. That was a big driving factor for us, especially once you get busy, you can't afford to have a machine down. So for us, it was the right move. It made sense to obviously invest and jump to a more capable, faster machine that can be more automated. So demo wasn't pre-organised enough to have spare batteries, and we ran out of batteries, and then some of the clips we recorded, we didn't have the microphone on. So you can see we're very experienced at doing recording. So day 2, and it's Monday morning. Yeah. So I think we finished off with the lathe. So pretty much this is our milling department here. This is our milling area. So we have the SMEC MCV 5700, which is a large 4-axis machine. We only have this machine since November, so 6-7 months ago. And before that, we had a 2-style machine, so an X11 and an X7, both sitting in that orientation. The X7 was a small 4-axis machine, and the X11 was a larger 3-axis machine with a 5-axis trunnion on it and a HSK 63A spindle. So
What made you change from the X7 to the X11? Obviously, I've seen that you can set up with 2 machines, obviously being replaced by 1. Why have you seen that?
Footprint and capabilities, I suppose. So the X7, while being like a really good machine, it was our first mill, allowed us to get into the milling like it was a cheaper barrier to entry machine. And to be fair to it, very, very capable. We put a lot of jobs through that machine that we got a lot of raised eyebrows when we said what we were doing with it, like large piling jobs with heavy milling operations. But But we struggle with loading larger jobs, and especially like high density work holding, like multiples of smaller jobs. So that sort of held us back a little bit. The X11 sort of similar as well. It was a 5-axis trunnion machine, so really good. We'd never done 5-axis machining before. 90% of it was positional, but we did have some simultaneous stuff in there as well. Really good to learn on and sort of cut our teeth into the 5-axis world. But again, being a trunnion based machine, you didn't have a massive capability for 5-axis jobs. They had to be relatively small, and then that trunnion took up a lot of space on the table, so then your 3-axis capability was limited as well. So we just started to get more more inquiries for bigger work, but we wanted to have the space to load multiple parts on the table at a time, get longer upcycle times, run unattended, load some pallets, and 5 o'clock in the evening, throw in a new pallet, hit run, and go home and get a few hours machining while we weren't here. So for us, moving to a bigger machine, a 4-axis machine, made sense. And with the distributor for SMEC in Australia, BJC Machinery, it again made sense to go with their machine again, just for the local support and what the machine offers. So it's a large, well, for us it's quite large. It's 1.6 meters travel in the X, 570 mil in the Y, and about 630 or 670 spindle height. So what we've done is, it's a 4-axis machine as well. We've got the 4-axis out at the minute to do this job. It's sitting on a pallet over there, but basically we've made a subplate to get the 4-axis up and off the table. So we've got as much room as possible. You can't really see it very well here. We might throw in a couple of pictures without the job on it, but we've got 8 0-point plates on pallets on the table, and they live on the machine all the time. So what we're trying to do is make our setups as efficient as possible. So 0 points on the table, vices go in. All our vices have adapter plates, or they're basically set up with the Lang fixture system. So different vices can just jump straight in, and then any vices that are non-standard, we will make subplates for them. So basically they drop in. We got some Kurt vices with some subplates there ready to go that will drop in as well. So pretty much we should be able to, same with our chucks as well. They'll all have subplates and to go straight into the machine. So trying to make it that we can just chop and change and throw work holding in and out of the machine as quickly as possible, and without having to break down setups and reset up. So just trying to make that work setup as quick and efficient as possible. Yeah, and that's like, it's still a work in progress. We are still sort of figuring out exactly what the best layout is, and trying not to take the 4-axis out. This is probably the first job we've actually had to take the 4-axis out of the machine to run, and we've ran some maybe plus 1.2 meter shafts with the 4-axis in there. FANUC controller, and then linked up to our cam system. So, and you see this is our sort of cam area here. We have our workstation with all our vices underneath here. All our sort of common fixturing that we're using to run the machine is in there. So the idea is out from there, straight in the machine, back out. Everything is pretty much at arm's reach within this little cell. We run our cam system from here. So we're running a Fusion. Fusion 360, and we have it linked over Ethernet into the FANUC controller. So just program, drag and drop. So yeah, that's pretty much the mill area, the 30 tool carousel. We run a standardized tool library. So we have all the holders, as you can see here. We have all the holders with their predefined tools already set up, ready to go. And then we have our tool tags, which we 3D printed, and then we have an Excel sheet that we control our tool library through, and then print out your tool tag and then stick it on, and that clips on there. So concept is that all the tools will be fully set up in their holders, and you just pop them in and out. Shouldn't have to reset tool lengths, shouldn't have to break down tools. Just a bit more of investment on the front side to have all your tool holders sitting there ready to go. Well, that's a growing progress. You can see here we have a standard tool library layout here, which is now being changed. So originally we were sort of limited to 99 tools and offsets in the controller, and now we've got that expanded out to 400. So pretty much we will group all our tooling depending on what the operation is. So all our drills will be grouped together, all our aluminium end mills or our softer material end mills will be grouped together, our harder material end mills grouped together with expansion. So as we expand our tool library or our tooling capabilities, then they slot into their relative groups, and just sort of keeps it quite organized. So, but again, that's a work in progress all the time. And then here we have our tool tag system, which many of you have seen. The likes of Pearson work holding runs this sort of stuff. So all the tools that are in the machine sit in your little holder there, and you can quickly see from looking at the front what tools are in the machine. And if you're doing job shop work, you can sort of tailor your programming to what tools are already set up and in there. So it just tries to make that that whole process a bit quicker. Again, we try to standardize all our tooling and all our tool organization. So we have a cart here. This is basically just to service the milling side of stuff. We constantly trying to improve this, so we've just got some cheap tactics boxes out of Bunnings, chopped them down because they got the divisions in them, and basically segregate them between your steel and your aluminium. All our drills, taps, that sort of stuff, pretty much all labelled and ready to go in there. All our collets live in there, and then some of our bigger stuff like our parallels and our slit saws and stuff. Again, a work in progress. We also do the same over on the lathe side. So we have a cart here that services just the lathe. This is some of the generic sort of stuff that we pull out. Our own coolant nozzles, all our turning holders segregated into their operation or their type. All of our sort of threading and sort of grooving inserts sit in the next drawer. Then we got our turning tools, boring bars, and then like sleeves and different adapters and stuff like that. Again, it's a constant work in progress, but that's the whole concept of the lean manufacturing, is that it's not just a one hit. You just organize everything in one hit. It's that continuous improvement and that little bit by bit every day that we try to do. And 6 months down the line, you look back at your shop and it'll be a much more organized place and much easier to work in. So, and everyone that is working with us now is on that sort of wavelength, and we promote that.
How do you find having the tool segregation for different areas makes it easier for like your lean manufacturing? So you mentioned before that you've got something as simple as Allen keys, full sets in the shop, right? You can say one per cell. Is that something that helps you grow capability, having the ability to put on staff and then come in, understand where they're at, and have the ability to find everything and just do their job?
Well, yeah, especially for new staff coming in, if you can say, right, this is your area, all the tools you need to do that job, are in this area, and it's pretty self-explanatory for where them to find it. I think that makes it easier for me to get them up to speed, but it also makes it easier for them to jump in and get straight into work, and not have to be worried about asking another co-worker, like, oh, can I borrow your Allen keys, or can I borrow this and that? Like, it just makes it easier. And even for anyone coming in and doing their normal day-to-day job, it just makes it easier. They know they can walk into an area, all my tools should be here, and very quickly, if there's something missing off the tool wall or out of the cabinet where it's supposed to be, then they can ask the questions like, well, where is this tool, or where, who has taken it to a different area? So, and again, it's a continuous improvement thing. So,
Quality of life improvements, only seems so small. Obviously, that kind of managing operating.
Yeah, quality of life improvements are a big thing for us. There's a very simple little thing which we can show here, is like all of these machines have access panels on the sides of them. And they're all Allen keys. So basically just a simple 3D printed knob that sits in there. It's got a magnet embedded into them, and it sits in there. It's got the hex on it, and that lives there. So you never have to take that out. So we've got one on this side here as well. So basically, if I want to open the lathe cover, I just twist that knob. No tools. I didn't have to go and get an Allen key. I didn't have to do anything. It's pretty much just drop it in, closed, and then move on to the next thing. So like, they are the little quality of life things that make a massive difference. When you add up all the times during the day that you have to go and find a set of Allen keys and open that thing, and then the Allen key is loose on the bench, or you've left it on top of the machine and then you can't find it. It's just those little things that makes I find makes a big difference for both me and for the people working here. And that's the philosophy of Lean, really, isn't it? That it's just constant improvement. So, yeah, well, that's pretty much the workshop floor. We have another little area. We got our compressor area upstairs. So you can see from here, so this whole mezzanine area, again, this was a blank canvas when we moved in. So myself and Chris took out this whole steel structure out of a workshop on the Gold Coast, brought it up here, retrofitted it. My brother came in and helped us do all the stud walling, and we basically made like a 40 square meter office upstairs off the floor, which would be pretty much unused space. So, and then we were able to put our compressor and dryer in the little access area that's not really been used. And then from there, we've got a header line that runs around and services all the machines. So we'll take a look up here. So it's a little bit dark and dreary, but basically this is our compressor area here. We've got a very cheap and cheerful Sydney Tools compressor, and we've got a dryer that's linked to a couple of filters and stuff that supplies the shop. So this is actually in the process of being changed. We're in the middle of a grant application for a new VSD compressor. So that will be pretty good. But as you see, that's the compressor kicked on there. It's pretty silent, but it's served its purpose, but it's probably time for us to move up to the next level, and that's the way we're going to go. So, and then this is our office area. So again, nothing really special. Like it's pretty rough and ready, but again, it's a full area, probably about 35-40 square meters that would be unused. I'm putting a mezzanine up here, got all the admin stuff off the floor. It gives me a place that I can go that's away from the machines, that I can try and work on quoting jobs and business development and stuff. And two of us operate out of here. So and all the admin and storage and our 3D printer, you can see, is all based up here. So it's pretty spacious. There's enough room, like, so. You just got to keep it nice and tidy, and it works. And this is some of the stuff that we have previously done. on the machines. We have some 5-axis parts that are aircraft parts for the defence, hydraulic glands for they're for lifting applications, so elevators for houses, so when people are putting elevators in for maybe people in wheelchairs getting into the second story of their house. So we do a fair few parts of them, glands and different sort of seals and that sort of stuff. So again, they come off our lathe, one and done operation, and we run them in batches of anywhere between 20 and 70, 80, something like that. We got some aircraft tools again, all done on the lathe, one and done. Some nice 5-axis molds that we done that have got some nice complex internal curves. We done these in batches, like quadrants and in halves as well. So that some nice stainless engraving plates that we done for the casino in Brisbane. That was last year. We had a decent run of small and large plates, and that was a prime example of trying to being limited by the size of our machine. So we ran these on the X7 and we had 200mm diameter plates and we could only fit 2 at a time. So it wasn't too bad. We still got like a 45-minute cycle to do 2, but if we could have loaded them, maybe if we could have put 10 in a bigger machine at a time, then we could run them overnight and get the jobs finished quicker. So that, again, stuff like that was sort of the driving factor for us to move to the bigger machine. Yeah, we recently just picked up a bamboo printer, and then we're doing all our little quality of life improvements, run that through there, and basically Chris and Candice on the floor, if they have an idea that they think is good, they have full reign to go and design it up and send it through the printer and see if it works. And it's a good cost-effective way to prototype new ideas, I suppose. So yeah, that is pretty much us in a nutshell. I'd like to say thank you again to Practical Machinist for giving us the opportunity to showcase our shop. It's a good chance for us to show people out there what we do and how we do it as a small business. If you'd like to find out more about us, we have a website. It's dkeng.com.au, and we are pretty active on Instagram. So you can catch us at DK Engineering and Machining on Instagram. And yeah, hope you guys enjoyed the shop tour, and yeah, thank you very much.